Have you ever really stopped to think about what happens to a single drop of rain? After it falls. It's not just a simple splash. No, every single drop takes this incredible, really complex journey. A journey that, and this is no exaggeration, literally shapes our entire world. Okay, let's get into it.
So we're going to follow the story of just one of these raindrops, starting from the second it begins to fall. We'll track it as it gets past trees, as it smacks into the ground, and as it finally, hopefully, gets into the soil. And by doing that, we'll get a much better handle on this delicate water balance that keeps our planet humming.
All right, first things first. Let's zoom all the way out. Before our little raindrop even starts its fall, it's part of this massive global system. But here's the thing. It's a system where the water is definitely not shared equally. It's more like a lottery.
Just try to wrap your head around this number. Every single year, about 110,000 cubic kilometers of rain, snow, and sleet fall on the Earth's land. That is a truly mind-boggling amount of water. The sheer scale of it is just immense.
But here's the catch. This map right here proves that the rain lottery is very, very real. I mean, you can see it plain as day in the data. The deep purples over places like the Amazon, they're getting drenched with over 2,000 millimeters a year. Meanwhile, the pale areas over the Sahara get practically nothing. And this distribution, well, it dictates pretty much everything.
Now check this out. This is where it gets really fascinating. When you put that precipitation map right next to a map of the world's biggest cities, the connection is, well, it's undeniable. We live where the water is. We've built our entire civilizations around these exact patterns of rainfall.
Okay, so let's zoom back into our one little raindrop. It's won the global lottery, it's heading for the ground, but its journey is far from over, not even close. First, it has to get past what's basically nature's umbrella, all the plants.
This first barrier actually has a name. It's called rainfall interception. And it's a simple idea, right? Plants just get in the way. But its effect is huge. A shockingly large amount of rain gets caught up in leaves and branches and just evaporates. It never even touches the ground it was headed for.
Let's look at a real-world example from Texas. In a grove of live oak trees, more than a quarter of all the rain that fell got snagged by the tree canopy alone. Then, another 20% or so was stopped by all the dead leaves on the ground. So, what's the bottom line? Barely over half of the rain, just 53.9%, actually made it into the soil.
And this chart just makes that crystal clear. You can see it right there. Almost half of the total rainfall, 46.1% if you add it up, was stopped before it could do its job and nourish the soil. That's a massive chunk of the water budget just gone right off the bat.
Okay, but what about the drops that do make it through the gauntlet? Well, their journey is about to get a whole lot more dramatic. You might picture a raindrop as this gentle little thing, but when it hits bare soil, it's anything but gentle. I absolutely love this quote from the source material. It says that raindrops strike the soil surface like minuscule bombs going off. And that's because even a tiny drop falling from way up high picks up a surprising amount of speed, and all that energy has to go somewhere.
And here, you can see exactly what they're talking about. This photo is incredible. It shows that minuscule bomb going off at the moment of impact. That little explosion of soil and water, it's called soil splash. And it is the very first step in soil erosion. The effect isn't always the same, though. It really depends on the soil. So on the left, you've got a drop hitting strong, healthy soil. See how it just kind of spreads out? But on the right, on weaker soil, that same drop creates a crater, blasting soil particles everywhere. Big difference, right?
So what happens over time? Well, this constant bombardment from millions and millions of raindrops starts to break down the soil structure. The tiny particles get washed into all the pores near the surface, and they form this hard, dense, almost waterproof layer. It's called a soil crust, and it basically seals the ground off, making it even harder for water to get in.
So far, we've only really talked about natural rain. But, we humans have become a huge player in this story. We've figured out how to make our own rain, deciding exactly when and where water hits the soil, all through the power of irrigation.
This chart here shows something pretty remarkable. That bar on the left, that's irrigated land. It only makes up about 20% of all the cropland on Earth. But now look at the bar on the right. That same 20% of land is responsible for a whopping 40% of our total food production. It's punching way above its weight, and it shows just how much we depend on irrigation to feed everyone.
Now, to make sense of this, scientists use these two really simple and useful terms:
Green water is the natural stuff, the precipitation we've been following this whole time. Blue water is the water we actively pull out of rivers, lakes, and from underground to use for irrigation. And that balance between green and blue is absolutely critical for global food security.
So you'd think the answer to water scarcity is easy, right? Just make our irrigation systems more efficient, use less water to grow the same amount of food. Simple. But does it actually work that way?
Well, it turns out there's this weird twist. It's called the paradox of irrigation efficiency. The theory is exactly what you'd think. Better tech means you save water. But the reality is often totally different. What happens is, when farmers get more efficient and save water on 1 acre, they often take that saved water and just start irrigating more acres. So the total amount of water being used doesn't go down at all. Sometimes it even goes up. It's a really counterintuitive problem.
So, what a trip, right? From a global lottery to a battle with plants and then a violent collision with the Earth, our little raindrop has been through a lot. Let's kind of pull it all together now and talk about why every single step in this process matters so much.
And we're back where we started, looking at this diagram. But now it makes a whole lot more sense, doesn't it? Every single one of these arrows, the interception, the impact, the infiltration, is a critical moment. Each step is a control point that determines if that water becomes a life-giving resource or if it's just lost to evaporation or damaging runoff. And that leaves us with one last big thought to chew on. As our climate changes, all of this is changing too. Rainfall patterns are shifting. Storms are getting more intense. Droughts are getting more common. This entire delicate journey we've just walked through is being fundamentally rewritten. So the really crucial question isn't just, how does the system work anymore? It's, how are we going to adapt to the new rules?